Okay, so you are going to have to complete all 20 of these slides, but some of these slides go pretty fast. And once you're done with the slides, I'll be able to look through them and give you full credit for today's attendance. Now, as I look through this, I want you to move this around. Notice what's changing. I also want you to move this around. The cat gets small, cat gets very large. Okay? So super simple to see. All right, now, next slide. That's all you had to do on that one. So that was super easy, right? This one, drag the point to make this toy cat taller than any of the other toy cats shown in the graph. Make sure the cat looks classy, which is kind of funny, all right? The cat needs to look classy and look taller. So if I did it over here, it says the bow tie is too big. So you click try again. Move it over a little bit, try it. The bow tie is too big. Okay, we know that this is the width of the bow tie. So let me try it again. Move it over here. And now that the bow tie is small enough, that's what we wanted to do for this one. Kind of silly, but I want you to get good at looking at the graph, looking at your x value, looking at the y value, look at the relationship between the two of them. Okay. All right, use the model to predict. Now we have a model here. We have a linear model, a line, a straight line of what they're predicting for the cats. Now, it says another toy cat is 65 centimeters tall. How wide should its bow tie be? If it's 65 meters, I'm going to use my straight line tool, and I want you to see this. 65 would be centimeters tall. That's up here. In between 60 and 70, isn't that where 65 would be? So I'm going to do a straight line tool. That's where 65 is, right here. All right, now, how tall should it be? You see it? All right, go ahead and take a look at it. If you want, you can go ahead and hit 20 and submit. Do you see why it's 20? All right, now, very cool. You put that in there, that's good, because this is going to help you on the next slide. Next slide says, you said the bow tie would be 20 centimeters wide. Press reveal to see if you're right. You are correct. And then this whole activity, this one was called Classy Cats, okay? Now, we're gonna, oops, let me go back to here. We're gonna go into something now about robots. This is kind of interesting, but look at the eye distance is your X, the height is your Y. As I go up, the robot gets taller. Get it? Because of the height, right? But as I go to the right, the eye distance between each other. You see the eyes moving? Creepy, right? And as I go this way on the eyes, it gets, whoa, they're going to turn into one even. All right? Then you can make your robot dance, all right? Get low, get low. I'm just kidding. All right, next slide. That's all you have to do is just play around with that slide. Now this one takes a little bit of time. It says move the points on the graph to represent each robot. I want you to play around with these points and try to guess, not really guess, because you can look at the graph and get a sense. Now if I look at this orange robot, it's tall, right? But the eyes are far apart. So which one of these points, where would I drag the orange? It's tall, but the eyes are far apart, okay? Go ahead and put these points where you think they should go. The purple's short, but the eyes are close. The blue's short, but the eyes are far apart. And the green's tall, but the eyes are close. You do the best you can. I'm not going to do every slide for you, all right? All right, for this one, you got to put numbers in here. Remember, if you're going to go over maybe 3, that's over 3 up 2. And look at where your point is. I want it exactly in the middle, though. So change your point to be perfectly in the middle. Let's go. Next slide. Over 5, maybe. Over 5 is your x. Remember, your x goes this way, left and right. Your x goes left and right. If I'm going positive 5, that's right here. Now, am I going up? No, I'm going down, which means my numbers should be negative, okay? Negative 4, look at where my point is. It's in the red, but I want it right in the middle of the red, okay? Keep it going, keep it going. Next slide. Consider the system of linear equations shown here. Drag the point to show its solution. You're allowed to drag this point to show where the answer is going to be. And I'm giving you a clue, and then explain your thinking. Why is that the answer? What have I told you that makes something a solution? You can type whatever you feel. Remember, it's a solution because you're going to type it. All right, here, is there an ordered pair that is a solution to the linear equations described both these lines? Ordered pair, fancy word for, is there a point? Is there a coordinate point? Like the bullseye, is there an X and a Y value? If there is, go ahead and put it in the box where after you hit yes, there is an answer. Explain your thinking. Does this system have a solution? If it goes up here, are they ever going to touch? Yeah, they are. And try to explain. You know what I want you to do? I want you to guess, where do they touch? Give me an answer. Where do you think they end up touching? All right. Does this one have a solution? Interesting. Does this one ever touch? Do they ever touch? Explain your thinking. All right, for this one, you got to give me an answer. In a y equals something, x, and something, make sure you understand what's the slope and what's the y-intercept. We went over this a ton. All right, for this one, how many months will they have the same amount of money? I want you to eventually scroll down here and solve this equation. I'm going to help you set it up to begin with. $50 per month plus 200. $50 per month plus 200 equals, what's this one? $25 per month plus 300. All right. And then you have this set up, then go ahead and, I forgot the month right there. Remember, you're going to go letters to the left. You're going to move this over here, and you're going to move your constants to the right and try to get to a final answer. All right. Do the best you can. Show me that you've at least written this down and trying to do work underneath it. You get the final answer, that'd be sweet. I want to know what M is at the very end. All right. Let's go. You got this. All right. Next one. Write out the equation to solve it without the y. How would you solve this equation without the y? What would you do? Remember, you would put this, all of this would go right here. So 10x plus 40 equals 2x plus 80. And that's the equation you would submit. Now what do I want to see? I want you to actually go for it. Just like we did before, letters to the left, constants to the right. All right, go ahead and do the best you can. I'm doing it fast because I'm doing a video right now, but I would like you to go letters to the left, subtract 2x from here. That would become 8x. Subtract 40 over here. That would become 40. 40 minus 80, or 80 minus 40. All right, do the best you can to get x all alone at the very end. All right, what about here? It says screen share. Obviously, this is what I used in class. I'm not here today, so you're going to go ahead and do it on your own. Remember, 2x plus 8. I'm going to bring down the 20. My 4x is coming down right here too. Now from here, don't forget, 6x. All right, and you're going to keep on going. Then you're going to subtract 8, and you're going to finish the problem off, okay? All right, you're going to get 6x equals 12. Well, what times 6 equals 12? That's what it's asking. You got to divide at the end. All right, go ahead and do the same on this screen, best you can. Distributive property, go ahead. All right, do the best you can. 3x and then negative 18. All right, that's going to be 3x and then negative 18. Don't forget to bring the other stuff down too. 2 more slides left. This one, just circle what is going to get replaced here. You're going to put all of this right here. You're going to shove this part here into this part of the problem. You're going to squeeze it in where the y is. There's no more y. Instead, you're going to replace the y with 2x plus 3, and this is what it looks like. Go ahead and try to solve this last problem, and you're done for the day. I will see all the slides you've worked on. I will see exactly your work, and I'm going to give you credit, attendance credit for what you've done. All right, Huskies, go for it. I'll talk to you later. Good job.